Let me explain what's happening in Florida's wetlands right now, because it's one of the strangest ecological stories I've ever read about. Here's the baseline. In the 1980s and 90s, people brought Burmese pythons into America as exotic pets. They were cheap. They were exotic. They looked amazing. Then they grew to 15, 18, 20 feet long. Owners didn't want them anymore, so they drove to the Everglades and let them go. That was the first mistake, but nobody understood it yet. Then, Hurricane Andrew hit in 1992. It destroyed commercial breeding facilities across South Florida. Hundreds more pythons got loose. What was a slow leak became a flood. That's when the actual problem started. Here's what I need you to understand about the Everglades ecosystem. Nothing there had ever evolved to fight a python. These animals didn't exist in that food web. No predator in Florida had ever learned what a python was. No animal had defensive strategies against them. The pythons arrived like living weapons into a landscape with zero evolutionary memory of how to handle them. The collapse was fast. I'm not talking decades here. Raccoon populations fell by 99.3%. Not declined. Collapsed. Opossums dropped 98.9%. Bobcats fell by 87.5%. Marsh rabbits, muskrats, cottontail rabbits functionally disappeared from areas they'd lived in for thousands of years. Adult white-tailed deer got swallowed whole. American alligators, ancient armored animals that survived the extinction of dinosaurs, were consumed in single meals. 58 different bird species have been pulled from python digestive systems. These are migratory birds that flew thousands of miles from Canada. They came to Florida to survive winter. Instead, they became food. This destruction didn't happen over centuries. It happened in decades. In some places, years. The math is simple. One female python makes 12 to 36 eggs per clutch, sometimes more. She lives for decades. She reproduces regularly. The native animals that were dying had no evolutionary defense. They weren't adapted to this threat. They had no survival strategy. The federal government eventually banned python imports. Florida launched bounty programs. They trained detection dogs. They deployed thermal drones. They ran competitive removal events that brought hunters across the country. Environmental, DNA sampling, acoustic monitoring, aerial thermal surveys. Every tool available went into the field. Multiple agencies coordinated. The Army Corps of Engineers got involved. Nothing worked. Dr. Frank Mazzotti is a wildlife ecologist at the University of Florida who studied this for over 2 decades. His assessment is direct. He estimates tens of thousands of pythons, possibly hundreds of thousands. An invisible army, perfectly camouflaged, perfectly patient, dismantling one of America's most irreplaceable ecosystems from the inside. The way I understand his position, he believes the Everglades are functionally lost. The ecosystem is being eaten alive, and we don't have a predator that can stop it. That's what he said. That's what the data showed. Every researcher who spent serious time on this problem reached the same conclusion. The pythons had won. Then something unexpected happened. Dr. Ian Bartoszek and his team at the Conservancy of Southwest Florida were running a tracking study. They implanted surgical transmitters into juvenile Burmese pythons, radio tracking through the wetlands, tracking movement patterns, hunting ranges, survival data, standard ecological field work, methodical, slow, the kind of work that ends up in spreadsheets. Then the transmitters started going dark. Python 19 was first. 3 weeks of perfect data, movement patterns, rest cycles, activity windows, then total stillness. Not the stillness of a cold animal slowing down. The kind of stillness that means one thing: dead. Bartoszek's team pushed through cypress roots and saw grass in chest-high water to reach the coordinates. When they arrived, there was nothing. No carcass, no blood, no drag marks, no shed skin, nothing disturbed, just a faint electronic pulse broadcasting from inside something else's body. Something had swallowed their python whole, transmitter and all, and it was still out there. 2 weeks later, October of the same year, 2 more signals flatlined, 2 more pythons gone. The transmitters pulsing from coordinates where pythons used to be. They brought the X-rays back to the lab. Bartoszek stood in front of the imaging screen and stared. A python spine curled inside an unknown stomach. One documented case involved an animal over 50 pounds, nearly 13 feet long, with its neck destroyed. Something had killed an apex predator and consumed it entirely. 3 pythons. 3 transmitters recovered from inside something unknown, something still out there hunting, operating in a swamp full of researchers and cameras, and not one person had seen it. To me, this is the moment the entire mystery pivots. The team had to figure out what could possibly swallow a 13-foot python whole. They ran every diagnostic. The equipment was functioning perfectly. The data was clean. Whatever was out there was real. It was large enough to consume a 13-foot snake, and it was good enough at disappearing that an experienced field crew hadn't caught a single glimpse. They went through every logical candidate. Giant alligator, no. Alligators crush prey. They death roll. They leave catastrophic damage. Shattered bones, torn tissue, partially consumed remains. These pythons had none of that. No wounds, no external marks, just gone. Florida panther, no. Panthers ambush. They bite through the skull or spine. They leave puncture wounds, claw marks, clear evidence of mammalian attack. Nothing. Black bear? Powerful, opportunistic. But bears don't swallow 13-foot snakes in a single piece. Nothing does that. They cycled through every serious predator in the Everglades food chain. Hawks, owls, other large constrictors. Nothing fit. So they did what desperate research teams do. They mounted cameras across the study area, trained them on every location where a signal had gone dark, and waited. Weeks of empty footage. Saw grass in the wind, waiting birds, the occasional raccoon, hour after hour of nothing, the kind of waiting that starts to feel like defeat. Then a researcher pulled up a clip one morning. The review session stopped. Nobody spoke for a long time. The predator on camera was small, a thick, dark-bodied snake, heavy and muscular, lying completely still in leaf litter at the water's edge, invisible against decomposing vegetation, a perfect ambush position. Then it moved. Explosive, surgical, instantaneous. It locked onto a juvenile python before the prey even registered what was happening. A Florida cottonmouth, a venomous pit viper, an animal every researcher on that team had stepped around on the trail without a second thought. The cottonmouth worked slowly and methodically. It unhinged its jaws around the python's tail and walked the entire body down its throat, inch by inch. A native snake eating an invasive snake. The X-ray imaging confirmed everything. In one documented case, the cottonmouth had consumed the python tail first, working the entire animal into its stomach. The cottonmouth measured between 34 and 42 inches. The python inside it was nearly as long. A snake consuming prey, almost its own size, pushing the outer boundary of what anyone believed physically possible. Here's why this matters. The Florida cottonmouth, scientifically Achistrodon conanti, is one of the most underestimated predators in North America. Adults measure 30 to 48 inches. Rare individuals push past 6 feet. They're heavy-bodied and muscular, built for semi-aquatic environments, flooded cypress swamps, drowned grass prairies, blackwater root systems. Exactly the landscape Burmese pythons moved into. This was always cottonmouth territory. The real weapon is what I found most interesting. Cottonmouths are pit vipers. Between their eyes and nostrils sit heat-sensing organs. They detect infrared radiation with extraordinary precision. They don't rely on sight or smell alone. They hunt in thermal signatures. Darkness doesn't matter. Camouflage doesn't matter. Even a cold-blooded python, slightly warmer than surrounding water after basking or digesting, produces enough thermal contrast to be found. There's no hiding from a cottonmouth in its own territory. The venom is hemotoxic, refined across millions of years to destroy tissue and blood cells from the inside. For smaller prey, envenomation is nearly always fatal within minutes. Bartoszek's team confirmed that cottonmouths regularly prey on 27 different snake species as part of their normal diet, including other cottonmouths. They are ophiophagus, snake eaters by evolutionary design, by instinct, by millions of years of hardwired behavior. This wasn't a new skill triggered by the python invasion. This is what cottonmouths have always done. Burmese pythons have simply been added to an already long menu. Their strategy against large or dangerous prey is precise. Strike and release. One fast, accurate bite. Then, withdraw and wait. Juvenile pythons at 18 inches haven't yet developed the crushing muscular force of adults. Once that venom enters the bloodstream, the outcome is determined. 3 confirmed kills in a single study area within months. That's not coincidence. That's a pattern. Biologists now believe cottonmouths have identified juvenile pythons as high-value, low-resistance targets. And they're exploiting that window with lethal efficiency. But here's what I found even more remarkable. The cottonmouths weren't fighting alone. Bartoszek's tracking data revealed something that had gone completely undocumented until the transmitters told the story. 5 of the 19 monitored pythons were killed by American alligators. One of those alligators measured just 9 feet. These ancient survivors hadn't surrendered their territory to the invasion. They'd been pushing back the entire time, quietly, continuously, completely unrecorded, not retreating, not adapting around the pythons, killing them. Then in June 2021, wildlife cameras captured something with no precedent in scientific literature anywhere. A bobcat attacked a python nest, not scavenging, not stumbling onto unguarded eggs, attacking. It engaged the nesting female directly, slashing with both front paws, driving her backward with pure aggression, then methodically raiding the clutch one egg at a time. First photographic evidence in history of a native mammal raiding a Burmese python nest. These bobcats, whose population had been decimated by the python invasion, weren't retreating. They weren't adapting to coexist with the threat. They were learning to dismantle it from the inside, developing new predatory behaviors within a single lifetime in direct response to a threat that hadn't existed in their territory a generation before. The cameras covering flooded areas documented owls and hawks pulling juvenile pythons from exposed positions at dusk and dawn, removing animals before they could grow into apex predators. Black bears were separately documented, taking pythons at multiple points. Florida panthers the same. An entire coalition. Pit vipers in the leaf litter. Raptors in the canopy. Bobcats at the nest. Alligators in the water. Bears in the brush. All operating independently. All converging on the same target. None of them coordinated. None of them directed. All of them doing what evolution spent millions of years preparing them to do. Defending territory from a competitor that didn't belong. But here's the brutal truth. It's not enough. Not yet. A single female Burmese python produces 12 to 36 eggs per clutch. Sometimes more. She coils around the nest through the full incubation period, shivering her muscles to generate heat, defending against anything that approaches. These animals mature quickly. They live for decades. The reproductive math is merciless, and it does not favor the defenders. Since Florida's removal program began, human hunters have taken more than 5,000 pythons from the wild. The 2024 Python Challenge eliminated nearly 200 animals in a single weekend. That sounds significant. Then Dr. Mazadi's assessment hits harder, barely scratching the surface. Pythons are masters of concealment, bordering on the supernatural. Researchers have walked within feet of coiled, fully alert animals and seen nothing. They slip beneath water for extended periods. They compress into spaces no search team would think to check. Vast stretches of their habitat remain unreachable on foot, but every action still matters. Every cottonmouth strike, every bobcat raid, every alligator kill, each one buys the Everglades more time. Time for native predators to refine new behaviors and pass them forward through generations. Time for researchers to develop better tools. Time for the ecosystem to remember at the deepest, biological level how to defend itself. The question nobody can answer yet is whether it's happening fast enough, whether the cottonmouth that learned to strike a juvenile python can pass that behavior through enough generations to bend the population curve, whether the bobcat raiding a nest this year teaches something that shifts the dynamic 10 years from now, whether all of it together adds up to something the reproductive math of a Burmese python cannot absorb and overcome. Bartoszek's study is still running. The cameras are still recording. The Conservancy of Southwest Florida is expanding the transmitter network, building a deeper record of predation events, watching for the signal that the native ecosystem is closing the gap. The way I understand it now, this is about speed. The python invasion happened in decades. The native response is happening in real time. A cottonmouth digesting a python with a transmitter still beeping inside. Less than a mile away, 100 eggs hatching. This war is just getting started. And the next discovery could change everything we thought we knew about how ecosystems actually fight back.